Thank you, everyone. Welcome. Welcome again to Innovation Summit 2025. Very happy to be here and very happy to be sharing the next few days with all of you. An exciting keynote from Olivier and the team just a few hours ago. And I was chatting with some friends and said, well, it's going to make my life a little bit easier because it kind of set the stage for what I'm talking about today. And what we're going to talk about today is liquid cooling. Liquid cooling in high-density data centers, high-density servers. And there's a couple of takeaways that I'm going to leave with you, and we're happy to take those conversations outside of the speaking hall here and onto the show floor if you're interested. But a couple of key points that I want you to walk away with today, and I'll highlight those as I get in there, as we start to change the way we think about data center design, more so than we've ever talked about it before. So we've all heard about these AI servers and these really deep, dense heat loads that are coming off of them. I'm going to try and give you some perspective on what that means, what it means to you, what it means to the industry. But what liquid cooling is really defining the industry, defining efficiency, not just defining how your data center operates, but defining how those IT assets operate once they're put into deployment. And to give you guys some perspective, we've been looking at this thermal challenge for many years at Motivair for many years. In fact, I was reminded by a chart that was put together by ASHRAE, the ASHRAE TC 9.9, it's American Society of Heating and Refrigeration Engineers, 6 or 7 years ago, where the whole industry got together, the leading silicon manufacturers, the leading server manufacturers, the leading hyperscalers that are making their own silicon in certain cases. And they were trying to define where the industry was going without sharing their secrets, right? And they came up with this chart that was called a degree of thermal difficulty. And that chart, based on those dates, looks exactly like what you're seeing there today. Almost a vertical wall. And so what's happened in the industry is we've got this increasing drive for more power, more processing power out of these chips, and therefore the servers, and that is the demand that pulls from the grid for energy, and that is the demand that's put on your data center from a thermal perspective. So it wasn't that long ago, if you look at this chart, it wasn't that long ago in 2021, we were deploying and talking about H100 NVIDIA GPUs that are 700 watt processors. We're now looking at 2.7 kilowatts or 2,700 watt processors on the horizon. That's an enormous, enormous amount of heat. And so from time to time, we try and characterize this for folks that aren't dealing with it every day, right? But someone once put it to me in this way, they did the math on this, and you remember when you see like a space shuttle re-entering orbit and the nose cone of that space shuttle is glowing red, bright red from the heat, from the friction of that space shuttle at re-entering atmosphere. The watts per square inch of these chips is more intense than the heat that nose cone is seeing re-entering atmosphere. Put another way, right, as we look forward, and we're talking about a 1 megawatt server rack in the future, it's the equivalent of 200 ovens from your kitchen being put into a single server rack. This is intense heat. And this type of heat has now overcome what's capable of rationally deploying with air cooling. And that's why there's so much talk about this, because there really is no other way to effectively and efficiently remove the heat from these systems unless you're doing it with liquid. And liquid isn't new. IBM was liquid cooling mainframes back in the 80s. So this is not a new science, but now it's a required science. And the only way to do it is to have done it in the past, right? To learn from experiences and go forward. And that's something that Motivair has been doing for a very long time. So my goal today is to help share that with you. But the first point I wanted to make is how dense these heat loads are. And it all starts with the chips. So historically, right, if we look at the data centers around the world, enterprise data centers, colos, many times it was build the data center and try and design it to cover the widest logical range, rational range of different IT assets that could go in there. Storage, different server manufacturers, blends of CPUs, maybe a little bit of GPUs, and generally speaking, the rack loads are 3, 5, 10 kilowatts would be high density. 15 kilowatts, you could manage that with containment systems. 20 kilowatts, you put rear door heat exchangers on it, or a lot of in-row coolers. These are all technologies that Motivair and Schneider Electric provide, but this is the background of where we've gone. But once you get to the point, right, once we cross the threshold of a 700-watt processor, that was about the end. Processors that are running at 700 watts and above will be liquid cooled, right? I was with a friend of mine in the industry that's one of the leading thermal engineers in the world for this type of technology. He works for one of the leading silicon manufacturers, but he said at 700 watts, we were bending the laws of physics to make that happen. Right? And if you look at H100 servers, tall 10U, 12U boxes, whatever those were, the heat sinks are this tall. Right? So it just doesn't become practical anymore to use air. It has to be liquid. And it's very dense. Right? And so Pankaj Sharma spoke earlier today about what we're doing, what we're enabling with liquid cooling, right? And this new metric that we're talking about, cost per AI token per kilowatt, right? Tokens, this information that's coming out of the AI factories, and how important it is that liquid cooling enables that, right? And to create a stable operating environment for these assets. In older air-cooled data centers, and air cooling is not going anywhere, just by the way, but in these traditional data centers, you could get away with a lot of wiggle room, right? You can turn the temperatures up and down, you can move air around the data center. But with liquid-cooled servers and GPUs, you will know the second you turn them on, if the liquid cooling isn't designed right, if that system isn't operating the way it should be, the client will know, the operators will know, like that. Because the GPUs will throttle and you won't get the performance. And that's really part of the investment that they're making. And so, when it comes to liquid cooling, it's really this integral part of the system. And so I've talked a little bit about air cooling and liquid cooling and where it's going, but you need to start thinking about data center design, and you got to start looking at the silicon and the chips. It starts with the chips. The chips are what's driving this, right? It's the insatiable demand for AI, and that's created by the chips themselves, right? So you need to be looking at kind of where the future is going, what the roadmaps are, which we've shown you just a minute ago, and then recognize that liquid cooling is here to stay, at least for the very foreseeable future. I'm not aware of a single roadmap product today in the industry, at least at the high-end processors, that is not using single-phase direct-to-chip liquid cooling. Everything is predicated and based on this. So getting comfortable with that is our job to help you, okay? And so what you're seeing now is this migration of air cooling to liquid cooling. And what you have is the cooling that used to be in a server with fans and air-cooled heat sinks is now migrating out of the server and being replaced by CDUs, TCS loops, right? That's the piping between the CDU and the server, right? Rear door heat exchangers, but the thermal removal of that energy coming out of the server, right? It's now being deployed in the data center, not in the server. So you got to pay particular attention to that. And it is, again, it's driven by the chips themselves. So what we help with is what we say delivering the platform, right? The industry is moving at unbelievable speed. It used to be that you'd have a chip refresh every 18 to 24 months, generally speaking. And we would see this. We would see this in factory load demand. We'd see, like, just before new chip technology was coming out, server sales would dip a little bit, and then the new technology would come out and the server sales would go back up. And we'd see that from the various partners that we deal with. But our job is to help you on this journey. It's to simplify the complexity, right? There's a lot that Motivair and Schneider Electric have been doing in the background. And again, Pankaj spoke about it. But we've been doing this for a very long time, more than a decade, right? And so our job is to simplify the complexity and accelerate the integration process. This is not something that you want to learn on the fly. The chips are coming out almost every 6 months, 6 to 9 months. That puts a burden on everybody in this room, everybody in our ecosystem. right? Because we have to keep developing products to support that. And Motivair is very good, always at the cutting edge for that. And our job is to help you reduce risk. The biggest thing that I do in my job is to help our customers and our own people in our own building from a business perspective is to mitigate and reduce risk. And when you have customers with the types of investments that they're making, unprecedented, maybe in the last 100 years, maybe unprecedented investments in recent human history, mitigating risk is really, really important. But you don't have to take my word for it, right? We've been doing this, like I said, for a long time, and you will find Motivair liquid cooling technology woven into the majority of the most advanced liquid-cooled compute systems ever developed, okay? In fact, marketing did a good research. 6 of the 10 fastest supercomputers in the world, 60% of the top 500 supercomputers in the world, right? And our teams come from this world. The people that develop our products are developing them in unison with the silicon itself. If you think about it, if NVIDIA is going to bring out a new chip, they can't sell it anymore without the right power and the right cooling available. So we have to have the cooling technology available before they launch that chip. And that's our job. And we've been doing it for a very long time. All right, so I've been part of Schneider Electric now since March. So Motivair was acquired by Schneider Electric in March, and it's been tremendous. But we took a look at the industry, right? And we saw this coming, this huge wave of opportunities. And we said, our customers need us everywhere at one time, instantly. And at the time, Motivair was primarily focused on North America, and we were selective outside of that world, but we needed to be everywhere at all times. And at the same time, Schneider Electric was looking for a dominant position, a leadership position in liquid cooling. Because if you look at their product portfolio at the time, it's one little key piece that was missing in this really interesting end-to-end solution proposition, and that was liquid cooling. And so when we looked at the world and we said, who are we best to partner with? We picked the best of the best, right? So we chose to merge with Schneider Electric, and it's been an exciting, exciting journey. So from a thermal chain, and Vandana and others here can talk about the full end-to-end solution of what we say grid to chip and chip to chiller, but specifically in the thermal area of moving energy from a server and out of a building, right? We have this really deep, extensive, battle-hardened product portfolio that manages every aspect of that. Motivair has dynamic cold plates that are designed to go in servers themselves. So when we actually look at product development, like our CDUs or our rear door heat exchangers, we're actually looking at the chip itself. What's happening at the core? Why is it that the memory is the hardest thing to cool in some of these chips, not the chips themselves? These are thermodynamic challenges, but we use that information to form the products that we develop, the products that land up in your data centers or in your customers' facilities. It's not an experiment. We're not reacting to the market. We see that a lot these days. A lot of companies reacting. Oh, they saw Motivair acquired by Schneider Electric. Now everybody has to own a CDU company, right? We've been doing it for a decade. We like our leadership position. It pushes us harder. But know that the products that we develop are developed based on silicon. I said that earlier when I started talking. It's all about the chips, okay? So it's also about the relationships and the role that you play in the ecosystem. Motivair has played a central role in the HPC and supercomputing ecosystem for a very long time. And now if you look around the industry, look at your biggest hyperscalers, look at the most advanced data centers, you'll see people that came from that industry that are now moved on. And we have the same. Our teams of product developers come from the supercomputing industry, deep experience and expertise. And then we use that to develop reference design. So this particular one here is highlighting a reference design, one of the several reference designs we've put together with NVIDIA, okay? And so that allows you to get to market faster in a more predictable way. So as we've expanded this business, we're now building product in multiple Schneider factories around the world. Motivair is based in Buffalo, New York. That's our headquarters. But we're now building CDUs and rear door heat exchangers in multiple factories to support our customers on a global level. And so when you look at this, right, when you look at what Schneider Electric is doing, what Motivair is doing with Schneider Electric together, right, it's not just about having leading products, right? It's about being able to connect everything. And that was a huge value for us as well when we became part of the Schneider Electric family, is we could now step in with a customer and predictively create a digital twin of a customer's data center, their thermal loads. Pull that all together before the customer even needs to put a shovel in the ground. We can predict what the outcomes are going to be, reducing risk, faster speed to market, okay? Then we layer on that best of breed products. It's battle tested, battle hardened products that are developed in line with silicon, in line with the chips, in line with the leading server manufacturers. So we know it's going to work before that arrives in your data center. And we put all that together. Now we provide a full portfolio of services, professional services from the get-go, laying these systems out, engineering them to your particular unique needs, and then services to install these systems, speed to market. I cannot stress enough how important that is today, speed to market, and then a full portfolio of services, professional services to take care of our customers on their full life journey, right? And that's been important as well. So since the day we became part of Schneider Electric, every single week, there's dozens of Schneider Electric, we call them FSRs, field service representatives, coming through the Buffalo factory for training, right? So as our customers deploy, we walk with them on that journey. It's a strong point of Motivair, and now we're taking our know-how and putting it out through the Schneider Electric ecosystem. So it's this end-to-end portfolio, right? Grid to chip, but in this room, we're talking about chip to chiller, where liquid cooling is going, and why it's so important to you. So with that, I could talk about this for days, right? With that, I'd like to bring up Vandana and Tomek to help join me on stage. We'll have a little Q&A. And again, I welcome everyone to find us on the floor around here if you'd like to talk more in detail. Thanks, Vandana.
Well, how is everyone doing today?
So great.
We all just had lunch. Let's ask again. How's everyone doing? Good? Good energy? Had a good morning session? Excellent. Well, look, my name is Vandana Singh, and I lead the Secure Power division at Schneider Electric. But in addition, I also have responsibility and the privilege of leading the data center practice for North America. And with that said, I want to make sure that I give a few minutes to Tomek to introduce himself.
Thank you, Vandana. My name is Tomek Koviak. I'm the VP of Product for Kolibor Data Centers. We're unique in the space because we've been doing liquid cooling for over a decade. I believe we were the first retail co-location to be fully liquid cooled, and that was in our SJC01 data center in Santa Clara, California, where we've helped many hardware manufacturers develop advanced AI systems. Some of them you may have heard of, like NVIDIA and their DGX product, and some of them maybe you haven't heard of yet, like D-Matrix. They just their third, they closed their third round. I think you're going to be hearing about them soon. But yeah, our kind of claim to fame is, we are a fully liquid cooled enterprise data center solution, but also serve as this kind of R&D facility for innovators in Silicon Valley.
That's great. That's a great introduction. So clearly this morning, everyone has heard a number of comments about the growth in AI and how it's fundamentally changing what we think of how we deploy, design, and service infrastructure, period, right? We've heard about kilowatt racks getting to be megawatt racks. We've also talked about how going forward, I think some of you might have sat in Jim Simonelli's session earlier. We talked about how in 2028, almost 7% of the energy generated in the US will be consumed by data centers. In 2030, 33, it'll be almost 16 to 23%. So this trend is here to stay. For those of us that have been in the data center industry for a while, this trend is here to stay, right? Now that said, there are two things I'll comment on, having been in the data center industry for over 25 years. Two things that make biggest difference in my mind is one, innovation from a product technology perspective, which is why we have Rich here, as well as Thomas. And secondly, is also innovation in terms of how we operationally execute that technology. Because what that means is that then we are in a place where we can build futuristic, resilient, reliable data centers that are software defined, but they're also scalable. And this is really the journey that we're on. So let me just ask you both this question in terms of like, what do you think are the most significant challenges operators will face as they scale to meet this AI demand? Let me start there. Tomas, you might want to start and then go with Rich.
Sure. Yeah, that is a heck of a question. I think one thing that comes to mind immediately is, AI workloads are unlike traditional IT workloads. They're quite spiky. So you can have multi-megawatt bursts and spikes, which are very difficult to predict and manage. So you have to create an internal ecosystem where you're basically in tune or harmonizing with those workloads. So what does that mean? That means connecting NVIDIA Mission Control for a DGX system with your BMS and orchestrating it in such a way to where the power side and the cooling side is actually working with the workload. And let me tell you, that is a heck of a challenge. Predicting inference at that scale and making sure your building is reacting properly is, it's 5 years ago would be an impossibility, but today it's a reality, thanks to partners like Schneider. But I would say that deploying that at scale and at a pace to meet the demand, that's probably the biggest challenge right now.
Yeah. Rich, what would you add to that?
I'll go a little more macro, but actually the last few words you said there resonated with me, and that's speed to market, right? There's this, when we look at the assets that are being deployed, when we look at the investments that customers are making, it's in some cases we have 90 days or they have 90 days to get those servers, if they get a chip allocation, to get those chips into servers and get them deployed. That is a unbelievably short runway to do that. So speed to market, I think, is the biggest challenge. And so what we're doing there, and I mentioned it a little bit earlier, is we're trying to take that risk and that guesswork out for the customers. So a lot of times it's paralysis by analysis, right? Customers haven't done this before, so they're overthinking things, which is okay. But our job is to try and provide that roadmap to get them there faster.
Great points. I'll steer towards the customer perspective now. This speed to market was a critical comment here. But Tomas, I'm going to ask you this question. Your journey with Schneider, specifically the innovation and the evolution you've done and been on with Schneider, when you tie that to speed to market, what would you share with the team in terms of your insights as well as your learnings?
Yeah, it's Schneider is a great accelerator, and I think maybe kind of give you some kind of anecdotal evidence of that. I think this comes through really well, with storytelling. So we have a 16 megawatt data center that we're going to be commissioning next year in July, fully liquid cooled. We're targeting GB300, which is a heck of a system to support. And we have a lot of neo clouds that are interested in taking down this capacity. There's like a long line of people who would like us to give that data center over. These clients are unique because they haven't figured it out. They know what they want to deliver, which is inference, and they know how to orchestrate GPUs, but there are a lot of gaps. So they come to us to fill those gaps, which is a position I've never been in the data center industry, right? Nobody asked the operator in the past, like, how do I deploy at scale? So they're asking us these questions, and a lot of them are very difficult for us to answer. We have a very specific design. We're very dependent on rear door heat exchangers because to us, that's the most efficient way to deliver flexibility and reliability. So the challenge we have is people have gotten allocations. They have the money, right? They have the capital to deploy. They want to use our data centers, but they don't really understand how to do that, and they have to get sign-off from NVIDIA, which is not an easy thing to do. So if you're operating a Neo Cloud and you think it's just a matter of finding a data center and getting the capital to buy the GPUs, guess what? You're in for a surprise because, the Godfather, Jensen, has to sign off on that deployment. So for us, it's easy because we have partners like Schneider, Motivair specifically in this case. We can hand off that customer to Motivair folks, like to Nick, and say, hey, can you just work with this customer and assure them that the rear door heat exchanger, which is necessary for our design, fits the NVIDIA spec, and can you get this approved through NVIDIA and fast track it, which they do. I don't know of any other ecosystem that can facilitate that, and it's pretty powerful. I mean, this is a business accelerant worth hundreds of millions of dollars to us for a data center. So that acceleration of the process and the ability of Motivair and Schneider to be nimble and agile, to come up with solutions to problems that didn't exist 6 months ago, is pretty remarkable.
It's great. Do you want to add anything, Rich, from the collaboration that Tomas is working on with, with your team?
Yeah, it's been mutually beneficial, right? So when you've got dialogue, when you're trying to move quickly, right, you want to have an established level of trust between both companies, that you're going towards a common goal. And I think when we look at that, being able to share information seamlessly, we'll know who the client is. It's always NDA protected, but we're able to move much faster because we've got a common goal to get this customer established and online, get their investments running as quickly as possible. And I think with the experience that Motivair brings, we talk that language like it's a second language, so we can go straight to the whatever the crux of the challenge is. It's almost never that we haven't seen some of these questions before, and we know how to solve those problems. So it gets Colivor going faster. It gets the customer in there faster. And again, I'll just hammer on this. And when you turn it on, it works. That's as simple as that sounds. I cannot state that enough. It actually works. Again, not a surprise to us, but I think huge value to the customer.
Yeah, I think it's a great point. I do want to add one. We're talking something here. There we go. We are talking about the collaboration that we're seeing between Schneider and Motivair. As you all know, as Rich mentioned, the grid to chip to chiller story. We have multiple deployments across the ecosystem, especially and also all the way from low voltage, medium voltage up to chiller execution, and in many instances in prefabricated environments, right? So we have multiple business cases that are positioned, that are, we're happy to learn and we're happy to teach. And if you haven't been at the hub, definitely suggest, making a trip to have a look at that. Now, I want to pivot that to a bit of a technology conversation with Rich. And your slides highlighted, we think that liquid cooling looks simple until we know that it's not simple, right? And I think Tomas just was talking about this. What do you think, right? Where do operators most underestimate the complexity? Is it on the technology piece? Is it on the integration piece? Or is it simply on the operational layer? Do you want to shed some light on that?
Well, I think from a product perspective, I think we take a lot of that complexity out of the equation. But I can tell you literally firsthand, when you're developing these systems at the cutting edge, and today the most dense rack is about 130, 140 kilowatts. We've been cooling 400 plus kilowatt liquid cooled racks for more than a decade. So when you're doing really cutting edge things, when the computers that you're cooling are there's a lot of important stuff on the other end, whether it's business or government or whatever. Every little aspect of that product has to be evaluated, tested, validated at nausea, which is a good thing, right? So we take the complexity out there. I think actually where some of the complexity or the challenges are overlooked is what seems simple, right? Connecting those CDUs, for example, to the liquid-cooled infrastructure. Every aspect of a wetted surface in these systems, right? So we have a primary side and a secondary side. The primary side is like the building chilled water system or the cooling tower system, whatever that is. That feeds down to the CDU. That's pretty standard, right? Other than load profiles and controls and things like that. That's not changing a whole lot, right? But from the CDU down to those loops, and depending on who's in this room, if you're a colo operator, the SLAs, and who's responsible for what. But those piping systems and the manifold kits that go inside the racks, I can tell you that the way that they're manufactured the critical nature of that is often overlooked, right? This is made from high quality 304, 316 grade stainless. You have to fabricate it in a special fabrication site. You can't have cross-contamination. If you're also welding carbon steel in that space, it's actually going to contaminate the stainless steel welds. That can destroy an entire loop, right? So fluid quality, there's whole groups of people inside the industry that all they do is focus on fluid quality, right? So material compatibility and fluid quality, while we kind of look at that like, oh, it's just a water with a glycol. No, it is not, right? We were the test bed for these fluids at Motivair a decade ago. We've seen that not all coolants are considered equal. Big names that you'd actually look at and think, wow, I can't believe that didn't pass the standard. Right? So do not use a coolant that's not recommended by the server manufacturer. That's another point I'll tell everybody, right? Do not. So fluid quality and material compatibility, you can work with us on that because we're the ones that basically wrote the standard on it and make sure that you don't put something in that loop that can contaminate the fluid, which can then contaminate the servers. And those are $300,000 to $500,000 a piece, right? It's not a problem you want to be dealing with. It's a problem we want to eliminate.
Yeah. Now, on that note about how complex and how expensive these systems are, let's talk a little bit about services, because we tend to leave out this aspect of you deploy great, fantastic systems which are right for your environment. How do you service it? What advice would you have for the team in terms of recommendations for services and making sure what to look in the partner that can provide the right service? Thoughts?
So I mentioned it towards the end of what I was saying earlier, how important these services are. It's these assets. The assets themselves are hugely valuable. We see that in the news every day, right? How much hyperscalers are spending to deploy these assets, especially these AI servers. That pales in comparison to the value of those IT assets to their business operations. A data center goes down. It's not $100 million of servers. It's $100 million an hour if those systems are down. So you need to have the right service teams that are experienced in how to manage these systems from a preventative, proactive situation. You really want to avoid, obviously, being in a reactive situation. But so having the right people trained nearby. Some of our larger customers, we actually embed service technicians into their data centers, right? So there's fast reaction time and an experience in how to manage those systems and keep them stable, online, and operational. The goal is realistically, you want your service teams in there doing proactive preventative maintenance and just in the shadows, right? I think that's the real value there.
That's great. Tomas, would you add anything to that in your daily life right now?
Yeah, I mean, I think you guys make it really easy for us. We thought about this earlier in the year, and our reaction to this problem was immediate and pretty simple. We just called Motivair and we just said, what should we be looking out for, and can you train our people? So I think we're going to come in January, and we're going to have a Colavor training session to really understand what to look for, what's at stake, and what we should be buying as far as services, and which field technicians are most valuable to us, what's the cadence that we should be aware of. So, again, to us, it's when we get to these problems where we know there's an easy answer from our partner, we just go and ask. And typically, we get that answer very quickly, and it also accelerates our time to business and our time to solution. So that's kind of how we look at it. We've been doing this a long time, probably longer than most, but in all that time, in the decade plus that we've been doing this, we've realized that often we don't have the answers, but these partnerships, that's what they're really all about. It's not just the equipment, it's the know-how.
Perfect. So, Rich, I want to pivot back to you on the technology segment here once more. Motivair and Schneider, have partnered world's most advanced AI deployments. You didn't quite touch the story that I love the most that Rich talked about when he came on board is all the HPC deployments that they did and they cut your teeth on there, right? I'd love for you to, share some of those stories in terms of how you learned, your best of breed industry practice there and how you're bringing that practice into the AI deployments, and how does kind of combining the Schneider Electric's electrical energy management competency with the Motivair competency, what value proposition and what's the differentiated value proposition that we bring to the customers? I think it's a pretty loaded question, but the story is a great story. So I would love for you to share that.
All right, I'll weave all that together.
Do it.
Okay. So actually, maybe I can tie Formula One in since that's coming up here this weekend. So when we look at supercomputing, when I first started in that part of the industry almost 15 years ago, the way it was explained to me by a gentleman much smarter than I could ever aspire to be. He said, "Look, when you're developing these supercomputers, he's like, you're developing something that's so advanced that eventually it becomes commercialized, but it gets funded by the government or big research institutions because that's like an investment that, for once, that's actually a good use of tax dollars, okay, I will say. But when this gentleman said, look, do you remember long ago, I think it was Ferrari came out with these paddle shifters for Formula One. They're now on minivans, right? So you talk about commercializing of a technology, but what happens, what we learned over the years, developing these types of systems is that every little detail matters. Because if you don't get it right, systems fail. People can die, right? We don't find the cure for COVID in time. That was Motivair's cooling technology that was running those systems to try and find cures for COVID during the pandemic, which was really interesting because I had very senior people from the biggest server manufacturers in the world and data centers calling me and asking me for access and information to these other sites. And I said, I can't disclose that. They said, no, they're standing in the room. We're all together. We're working together on these types of systems, and we want to crank your cooling system up. When you're working on those types of systems at 400 kW racks, you learn that perfection is required. It's not an option. And so I think, that theme kind of runs through our products. And no, we're not perfect all the time, but that is always the goal, right? And so when you take that now, and when we see this commercialization of supercomputing and HPE, that's what these large language modeling server systems are, these clusters, right? These massive data halls full of systems. It is just I don't mean to make light of it, commercialized. It's a more commercialized version of supercomputing, right? And we talk, Tomac was just talking about how important it is to control these things. When you can step into a system like that and you can lay it out in advance, when you can make sure that you've got the right control layers, the right predictive design happening before, and you can kind of layer all these things together, you get two things. You get a predictable outcome, right? And you get optimization. Optimization, meaning more efficiencies, better use of your power, right? And that is, again, for me, being now part of Schneider Electric, it's very exciting because I can sit in meetings with customers and we can talk about, and I don't propose to be the expert on the power side of things, but I can I can pull and draw in different resources from Schneider, from Vandana's team to say, look, you're missing something here, right? We pull in the power team because you're missing an opportunity here to optimize, or we'll grab someone from the chiller team, whether it's Motivair's chiller line or Schneider's chiller line, doesn't matter. It's all one company now. And we say, hey, tweak that design. Get with this customer and tweak this design, because if you can just increase that temperature by 3 degrees, right, the system is going to perform better, and you're going to save more money on your operational costs, but that energy can go back in to make more tokens, right? So this unified product offering is really powerful. I mean, powerful. Look, I studied everything in the market. I don't know another supplier in the industry that has this breadth of product and experience that can be brought to bear with the challenges that the industry has today, with the speed at which we need to move. It's a very, very powerful resource, I think, for people in this room and our customers.
Great, and thanks for stitching a whole sequence of questions which weren't on the question tracker over here. So
you asked me 6 questions. I had to give you 7 answers.
I did. There you go. Well, you're supposed to be following this tracker, but I'm not really. But
I don't have my glasses on. I can't read it.
It is even better. So let's kind of bring it back to you, Tamak. Rich provided a perspective as a fairly new Schneider family member. I would love a customer perspective on this, right? What do our customers most care about is an integrated solution and an integrated ability to execute that solution and then service the solution. So you are consuming everything from power control, power, cooling, software controls. Can you talk to us about what you look for that one accountable partner to bring to the table? And please, if there's something that Schneider is not doing well that you would give us feedback on, I'd love to take that here. That's completely fine by me.
I think this is an easy thing to answer, considering the venue. We utilize every part of the Schneider ecosystem that is, creating solutions for AI data centers, which is our core business. But I think one thing that is maybe not talked about enough is, so we kind of, I think we all visualize the partnership as like, okay, well, I have a problem, Schneider has the answer, right? There's a product set or a bunch of SKUs and services and know-how. But what's interesting to me in the partnership is having access to that kind of like mind capital at Schneider that understands what's coming in the next 2, 3, 5, 10 years. Mm-hmm. So we can start thinking about it and we can start preparing for it. One of my favorite people to listen to is your Joe Reale. Mm-hmm. He has some incredible insights into how we should be collaborating with utilities and how to take gigawatts of stranded power and convert that back into token generation. So he's basically, in his mind, he solved this power problem in a very unique way. He calls it the 4-lane highway concept. I think I may be giving up too much. There's, just forget I said that. Don't go and research Joe Reale. But to me, there's incredible value there because it makes us ready for the future. It makes us sound really smart. Our customers love the fact that we're always ready before they need us. And that is something I feel is very unique to Schneider, that ability to kind of be that far ahead, years ahead. Mm-hmm. So not reacting at the last minute, but being prepared for what's happening. I think it's pretty remarkable. And to me, really that's the biggest value. That's what we can't find anywhere else.
Thank you. I thought that was a fantastic response, primarily because for me, my passion is just that, is how do you get to ideate and be creative to define, a future-proof AI ecosystem. And you probably heard in the previous session with Jim and, from the leadership from Compass Data Centers, the best part of my 4 years at Schneider has been working on one creative solution after the other with one customer at a time. But that should be scalable. That should be standardized. That should be serviceable, right? And that's the best part of what we do, what we look forward to. And so this whole concept of partnership with customers, partnership with our future partners and our current family is, I think, really what makes the difference and drives change in the AI ecosystem. With that said, it's exactly 000. Thank you very much for your time today, and I hope you take the opportunity to visit the hub. And we've got the Schneider leadership team here, so let us know where we can help. And thanks, Tomas, and thanks, Rich.
Yep.